So what would a horror game be without a few lock puzzles? Every good horror game has some lock puzzles. In this episode, we're going to be creating a simple combination lock with 4 different dials, and you have to put in the correct code in order to unlock the lock. But the logic of how we create this lock should help you put you in the right direction of how to create puzzles in general. So we need to import the lock. First, I made a quick lock mesh in Blender. I've been making more and more complex meshes as we go along that you can replace with your own. When you're getting your own lock, you want the lock itself and the dials to be separate meshes because the dials will turn independently. But let's import that now. So let's go into props and meshes, and let's hit import. And once you've found where you downloaded the lock, we have these 5 FBX files right here. This lock and lock dial, those are the meshes that we'll be using. This box and box top, this is just a quick chest mesh that I made for something to actually put the lock on. It won't have any functionality. I just wanted something to put the lock on. And the lock open right here, this is an animation I made for the lock opening. So first, we're just going to import these 4 so we don't get overwhelmed. So hit open, not a skeletal mesh, auto-generate collision is fine. The transforms are all good, and create new materials is fine. And let's say import all, so all will import with those same values. So it created our materials here, and it imported a texture. So one of my materials had a texture on it. So first, let's just go over this box. I just have a hollow box, and then a top for that box with a little latch I just created. I don't know, I got a little carried away. I was having fun. And then we have our lock here. Oop, focus in on it. There we go. And our lock dial. And this one's very small. There will be 4 of them on our lock. And this one has this material right here, but that I believe is a Blender material that I use that's just a part of Blender to set the UVs up correctly, but we'll have to change it. So let's see what the box uses. It uses material 6, material 7. I'm just going to make it those the same material. So I'm going to delete material 7. And I'm just going to take material 6. We can make it some kind of brown color. It doesn't matter too much. I didn't make a material for it when I made it in Blender. So let's just kind of maybe like a dark brown like that. Oh, it's a light brown for sure, but a dark brown. Okay. And you can obviously mess this around with as many things as you want. Turn the roughness up to like 0.9. Sure, that looks fine to me. So box and seems like box top. Oh, that's because material 7 was not for the box top. It was for this latch here. Can't seem to focus on it though. So that is my bad. Sorry about that. We will need a material for that. So it's just going to create it. We can call it M box latch. And this can be, I don't know, this can be white. I'm going to hold down 3 and click. This will give us a 3 vector, which can create a color. I'm just going to make it white for now. And that's fine. I don't need anything else. And then in the box top right here for our element 1 material, I will search for box latch, and now it's white. Let's rename material 6 to M box, and those are good to go. Now let's change the color of our lock. Our lock also has 2 materials. One is for this this top part here that will be metal. This one I'm just going to make it a solid color like I've done with everything else. And that is material 3 and 4. So let's take 3, which is the metal one. And here on this metallic, we can hold down 1 to create a constant. Click. And let's go to 1 value of metallic and see how that looks. Okay, maybe bring the color of this down. It's a bit more of a gray. Sure, yeah, that looks good to me. And yeah, that looks good. And material 04 is the solid color. We can make it kind of an orangey. Let's see. It's a little bright. I'm gonna bring down the darkness, and that looks fine to me. I mean, you can mess around with what you want, create a couple constants, maybe make it a bit more metallic, like 0.7. Bring the roughness up a bit. Whatever you want, that looks fine to me. Just gonna save and compile. And yeah, I like the look of that. So we will call this block metal and block body. Now for material 5, it's got this texture on it, but this is, like I said earlier, this is not the correct texture. This I created in Blender, I believe. So we're gonna have to replace it. And I actually did create a texture for this. I think I just forgot to put it in my resources folder. So let's import, and I cut so I could add it to my resource folder, and it's right here, dial base color. This will be in the downloads file for this episode, and we can hit open. And this is just a 0 through 9 texture that we will replace this. So it's called dial base color. So let's just take the texture sample, just search for dial base color, and this is the texture we want. And I'm going to just up the roughness to 0.9, and maybe the metallic to something a little high as well. All right, so we can now, let's hit save all. We can delete this dial texture reference because we don't actually use it, just imported with it. We have these 5 new materials. I'm gonna open the sources panel right here, and in prompts, we're inside our meshes folder right now, but we have these materials and textures folder, so let's move these to the appropriate places. I'm gonna select all 5 materials, drag it over the materials folder under prompts, move here, and I will do the same with dial base color into textures, move here, and that, now we have it. Our dial base color is in there, and our new materials are in here. Now there's actually one thing I realized that I actually made a mistake of. The lock mesh right here, since we imported all of them as static meshes, the lock also imported as a static mesh, but the lock is actually supposed to be a skeletal mesh. The skeleton does not need to be a part of the mesh for our code to work. That actually, the only reason I did it is so I could create an open animation for when the lock is open. We could make it work with a static mesh for sure. It doesn't need to be skeletal, but it wouldn't be able to have an animation, and I just wanted to add one in. So we're going to actually delete the lock mesh and re-import it as a skeletal mesh. So import lock FBX open, and we want to have skeletal mesh checked here. Import mesh checked, leave the skeleton blank, import geometry and skinning weights is fine. Import animations, we're going to leave blank because we'll import the animation separately. And we do not want to create new materials since we already have some, so do not create material, and don't import textures even though we don't have any. And we'll just hit import, and now we have our skeletal mesh right here. Bone size is too small to create physics asset, that is fine, we don't need one. So now when we open it, it is a skeletal mesh. We can click on the skeleton tree, and we can look at all these bones. I decided to add dial bones, so it would be easier to place our dials exactly where we need them. And it's already automatically found its materials, but if it didn't, just go to the asset details and add them right here. Alright, did I forget to rename these? I don't think I did, so I don't know why they're called material 3 and material 4 here, but it's fine. I'm just going to replace them. So I want to create some sockets for positioning the dials. And like I mentioned, I made the bones in the correct positions, so we don't have to position these sockets manually. So we're going to add 4 sockets, under one under each of these bones. So I'm going to right click, and I'm going to hit add socket. And we can call this, actually dial bone 1 socket is fine. The socket is way too big by default, so we need to make the size a lot smaller. For some reason I don't have my details panel, so I'm just going to go to window and hit details, and now we have our details. You can rename it here. That's the bone name, you want to leave that alone. And we have our location, rotation, and scale. We can leave the location and rotation, that's what I made the bones for, so we don't have to worry about positioning. But the scale is way too big, so we're going to make it 0.05 on all axes, I mean. Sorry about that. I'm sorry, not 0.5, 0.05, something real small. There we go. Oops. Let's just duplicate this, Command C, or Control C, Control V, and let's drag it under dial bone 2, and then let's just rename it to 2, and then, sorry, not 20, just 2, and take out that 0, and I'm just gonna Control V again, and Control V again, and let's just rename these once more, so dial bone 3 socket, and dial bone 4 socket. Alright, save. So now we have our 4 sockets right here, and this is what we will parent our dials to in our actor. So while we're here, let's go ahead and import the animation, just because we're importing everything. I'm going to just start closing all of these except for the lock, since we don't need them anymore. And let's make a new folder for animations. So we're in props right now. So new folder, animations, and we can hit import. And the last thing that should be in your list here is this lock open FBX. Hit open. It's a skeletal mesh. We do not want to import the mesh because we've already done that, so uncheck that. And we need to choose a skeleton, and this is our lock skeleton. Animation length is exported time, and everything else should be good, so we'll hit import, and now if we open it, we can see that's just that little lock opening animation. Just something a little fun that we can play once we've unlocked it, so our player knows that they have succeeded. Alright, so now that we've got all our importing done, let's actually create our actor. So let's go into Blueprints and Actors. And I'm just going to create it outside of a folder since it's just the one. So right click Blueprint class of type actor, and we will call it BP lock. We can open it. I'm going to get rid of this default scene root by adding a scene and just making it the root by dragging it on top. And we need to add a skeletal mesh. You can probably already guess what this is going to be. It is our lock. So over here in skeletal mesh, we can click on lock and press F to focus on it, and there we go. Now our dials are going to be separate actors in themselves. So let's go back into level 1, and let's right click, and let's add blueprint class, actor, BP, lock, dial. Because these will have their own functionality. So we can open it up. And once again, add a scene as the root. And this time we need a static mesh. And this will be called lock, dial, mesh. Probably should have added mesh onto this one as well, but it's fine. And the static mesh will be our lock, dial. This one's very small. You can hit F to zoom in. Take a look at it. Our mesh needs to be changed to overlap all instead of block all dynamic. Overlap all. This is so we don't have collision issues when we're trying to rotate our mesh, because it'll be kind of inside these lock sections, I guess I should call them. Alright, well now that we're back in BP lock, let's go to our begin play. And we need to spawn our actors, our BP lock dial actors, in all 4 of these areas. So we'll make a for loop. Actually, before we create the for loop, let's just go over spawning the actor itself, and then we'll add a for loop after that. So let's add spawn actor from class. And the class we want is BP lock dial, which we just created. And then it needs a transform. This is telling it where to spawn, and this is why we created our sockets, so it has an exact location for them to spawn. So let's just split this for now. So we have location, rotation, and scale. Collision handling override. We want to always spawn, ignore collisions. And now that we've gone over that, let's add our for loop now. So for loop is just a regular for loop right here, because we just need to do it 4 times. So first index is 3, last index, or first index is 0, last index is 3. So this is called 4 times. And now, technically, when we play, we won't really be able to see them because it'll be like right inside the lock, but once we spawned into our world, our lock would spawn 4 of these BP lock dials right in the center of the lock, all overlapping with each other. So we need a variable to be able to reference our lock dials. So let's take this return value and promote it to a variable, and we can just call it dials. And we need it as an array because we have multiple of them. So if we, oh, not there, sorry. If we go up here in the details, we can click this and we can change it to an array. It's going to complain because it won't be able to plug into our spawn actor, but we can hit change variable type. Won't have any errors. We just have to break that link right there. And actually, let's just delete that in total. Instead, let's take it out, let's get dials, and what we want to do is add. So we want to add a reference to this actor 4 times, and those 4 times will be the 4 dials that spawn in this actor. So after this, we need to actually set them to our sockets. So we're still inside the for loop here. So we can just get an attach to, oh, sorry about that, attach to component. The target is our lock dial right here. So we can just take the return value and plug it into target. I'm going to bring this up a bit. The parent is our lock mesh right here. And then we have socket name. So we can't just hard code the socket name in, because if we only put 1, then all 4 would spawn in the same socket name. So we need to change it based off this index from the for loop. So we can get a select node, and we're just hard coding this in this way. There's probably a more dynamic way to do it, but we know we'll only ever have these 4, so there's no issue with just typing each 4 individually. So based off the index, we know we have these 4. And we can just write all 4 of them. Now we want to make sure we get the socket names exactly correct. So we can go back into our lock, and we have dialbone 1 socket, dialbone 2 socket, dialbone 3 socket, etc. So just type in dialbone 1 socket. I'm just going to copy and paste this, and then just change this to 2, 3, and 4. Now for the location, we want to snap to target, which will snap it to the socket location. Rotation, snap to target, and scale, we will keep world, so it'll keep its original scale. Oh, I'm sorry, rotation we don't want snap to target, we want keep world as well. We just want it to snap as location. So we can actually test to see if the dials spawn in correctly if we put this in our world. So let's take our BP lock. It's rather small now, but we'll be able to see it. We can hit play. It's just floating there by our locker. Actually, before we do, let's take a look at it when we're not playing. We can see that it's, since we're not playing, since we're not in runtime, no dials have spawned. But when we hit play, and this begin play here is fired, we walk up to it, we now see we have these, oh, well, crouching's too short and standing's too tall. We have these 4 dials in there, and they're all facing 0. I'm gonna bring that up a bit. No idea how, yeah, I brought it up way too high. That's all right. You guys can see what's happening. So now let's add some variables to our dials. So we can go to our lock dial, because we need the ability to actually turn these. And we need the ability to know which number is facing towards us, so we can tell if we've got the correct code. So a few things we need. The first is an index. This will let it know whether it's lock number 0, 1, 2, or 3. So this is an integer. This allows us to make sure that we put our code in the correct order, because we don't want them to be able to put the numbers in any order. It needs to be the correct order. And the index should be instance editable and exposed on spawn. And before we continue, we can actually just, here if we have our spawn actor BP lock dial, if we right click and refresh it, since we set our index to be exposed on spawn, it shows up here now, and we can just plug in our index to our index right there. So now one of these will be assigned to 0, 1, 2, and 3, which is exactly what we need. We used a very similar technique when we made our inventory slots, because each one of our inventory slots also has an index. So the second variable we need is also an integer, and it'll be called number. This is the number that's 0 through 9 that's correct for that specific dial, since each one will have one correct number. So how do we let this know what number it is currently displaying? And this will be based off our rotation. So you notice we have our 0 facing out right now, and our rotation on our x-axis is at 0 degrees. This dial has 10 sides because it's 0 through 9. And if we were to rotate it a complete 360 degrees, it would look like absolutely nothing's changed because it's rotated once all the way around. So every number is based off 360 divided by 10, which is 36. And you can see it's rotated, and now 1 is facing out. So the numbers are solely based off of which number is the number that's divisible by 36. So we can also have 72, and that gives us 2. And we can keep going. I'm not going to save you the embarrassment of me trying to figure out how to add 36 to each of all of these, and we'll just set it back to 0. So to put everything I just said into one sentence, we just divide our x rotation by 36, and that gives us our number. So we can create a custom event, and we can just call it find number, and we'll just get the dial mesh, and we need to get its rotation, get relative rotation. We only need it on the x-axis, so we can split this, and we can just get the x divided by 36, and this will, and then we can set our number. So I actually got, I'm sorry, I think I mislabeled what this variable is used for. This number variable is actually the number it's displaying, not the number it needs to be. I believe I said that, so my apologies. This number variable is the number it's displaying. So right now, this variable would be 0. If we rotate it 36 degrees, it would be 1. Now, one clear problem we have with this is our number will keep going up forever as we rotate above 360. So if we were to rotate it to the number 360, instead of going back to 0, our number would become 10. So we don't want that. It's an easy fix. So, and we do this by, in our event, setting our dial back to 0 once it reaches 360. And since those look the exact same to the naked eye, we don't see it resetting its rotation. But we're going to do that in a separate part of code, so we'll save it for later. In begin play, we just want to call find number, so we can set our number variable. So just call find number. And we need a new variable. I'm going to call this dial rotation. And this is going to be the actual rotation of the dial, not that number divided by 36. So we'll have to make it a float. And we also need a variable called can rotate, and this is a Boolean. We're making this because we don't want to be able to rotate our dial while it's in the middle of rotating, since we're going to create a timeline to make it actually rotate. We don't want to be able to rotate it again while it's in the middle of that timeline, because it's going to mess up what number it displays and what number it's supposed to be, etc. So let's create a custom event for actually rotating the dial, and we'll just call it rotate dial. Oops. And before we get started, let's make sure our can rotate Boolean is set to true by default, because we want to be able to rotate it. And before we rotate the dial, we want to do exactly what I was just saying and check that we actually are allowed to. So if it's true, before we start actually rotating it, we want to set can rotate to false so that we can't. And then we want to create a timeline to actually rotate it. So search for timeline, and we will call this rotate dial TL for timeline. And we want this to play from start. So we can open it up. We can add a float track, and we're going to call this alpha, as always. And we can change the length to however long we want it to take to rotate the dial. I'm going to do half a second, so 0.5. And I'm going to add 2 keys, like always, and just make a graph going from 0 to 1. So time 0, value 0, and time 0.5, and value 1. These 2 icons to fit it to the screen, select both, and I'm going to change this to auto for a smoother rotation. So back in the event graph, we just have to get the mesh, set the rotation, so set relative rotation, put that into the update. We only need the X, so we can split this. And we just want to take the rotation we have and add 36 to it. So we'll grab our dial rotation, which keeps track of the rotation, or which will keep track of the rotation our mesh is at. We haven't set that yet, but we will. And we just want to add this 36. But since this alpha only goes from 0 to 1, we need to do this with a lerp. This goes into the alpha. And A is 0 and B is 36. So as the timeline goes on, it adds 1 and then 2 and then 3, not on top of each other, but it in the end it'll add only 36. And plug that into the new rotation for X. Now once it's finished, this is where we figure out if the dial rotation is 360, we want to reset that back to 0 so it doesn't keep adding up and up and up. So first, we want to just set the dial rotation, and before anything, we're just going to set it to this number that our rotation is at, and then we'll check if it's above 360, and if it is, we'll update it to go back to 0, but if not, it'll just be set. So we can get a branch right here, and we'll just grab our dial rotation, ask if it's greater than or equal to 360. And if that's true, we want to set our dial rotation back to 0. Now remember, this dial rotation doesn't directly control the rotation of the lock dial mesh, so we will also have to set the relative rotation on the X back to 0. And since these are 0 automatically, we can just leave this to look like that. Now, so once our dial rotates and then finishes and then figures out if it should be reset to 0, we want to find our new number, because our number is what we'll be checking to see if it's equal to the correct number. So after it finishes rotating, we will find the number. Now we also want to find the number if we aren't resetting the dial rotation. So off the false from this branch, we also want to find number. And I will create reroute nodes. After all of this is done, we want to be able to rotate again, because remember we set our can rotate to false as this all happens. And once it's figured out its number and finished rotating, we can now rotate it again. So we will set that to true. Now in find number, we want to replace the lock dial mesh relative rotation with our dial rotation, since this is the one being directly controlled by our rotate dial. So let's test this out if this works, because we added a lot of code, and I hope you're able to keep up. But before we continue, let's do some debugging to make sure everything works. So in find number, once we find the number, let's just print the string of what the number is to make sure we are going 0 through 9. And then in begin play, let's just rotate the dial every second so we don't have to personally interact with it. So we can just do that by setting a timer by function name. Our function name is rotate dial. Rotate dial. Time is 1 second. Looping is true. And to make sure we get there in time, we can just set the initial start delay to like 2 seconds. So it'll wait 2 seconds before it starts. All right, so let's test this out. So when we hit play, it should wait 2 seconds, and then the numbers that will appear, or the dials that will appear in our lock, will start rotating to the next numbers every 1 second, and our number should appear in the top left, and it should match what we're seeing. So 1, 2, there we go, 2, 3, 4, 5, and when it loops, it should come back to 0 in the upper left. 9, 0. Perfect. Look at that. So we're getting all 4 rotating, and it also knows what each dial's number is. But it looks kind of weird that all of them are starting at 0, right? And even in your game, to give that little extra challenge, you might want every number to start at just a random number. So we can add that in as well. So I'm just going to disconnect this set timer for now, but I might want to reuse it, so I'm just going to put it up there. And you definitely don't have to make them all start at random numbers if you want. You can leave them all at 0 if it's something you desire. But for us, we're going to make a function, and we're going to call it set random number. And we just have to get, or I think it's just called random int, random integer in range is what we want. And we wanted a number between 0 and 9. Both of these are inclusive. And then we could just multiply that number by a float. And that will be 36. And this is because we need to set the correct rotation for our lock dial mesh. So whatever it chooses, we need to multiply it by 36. And we can promote this to a local variable, and we will just call it local rotation. And let's get our dial mesh, set relative rotation, and we'll split this because we only want it for the x. The x will be our local rotation. We also want to set our dial rotation variable to local rotation as well, because we want to keep both of those updated and on the same page. And the only reason we made this a local variable instead of just plugging this into both is because every time this would create separate numbers for both of these. So if we were to just put these in here, when it called set relative rotation, then it would call these two and we get a number. And then when we set dial rotation, it would call these again and we would get a different number. And that is why we use the local variable. After we set these, we want to call our find number event so that it also sets our number variable to the correct number. And in our begin play, after find number, actually instead of find number, since we have a find number in there, we can just call set random number. And that'll set our number variables as well. So we don't need find number there. So now if we hit play and we go over to our lock, look at that, it says 5698. I'm gonna bring this down just slightly again. Just want it in eye level. And then we should get something different this time. 4357, perfect. You also might have noticed, I should have pointed this out earlier, but the numbers that get printed on the top left will also match. But you have to read them from bottom to top, since the first one will appear on the bottom, second bottom, if that makes sense. So if we look at the top left, it's 0112, and then here 0112. Perfect. Now we need to set a code in our BP lock now. And while we're in here, let's go ahead and add a variable for is unlocked. And this will be a Boolean, but we don't want an array, so change this to a single variable. And so to create our code, we need to know our 4 numbers and which dial they're connected to, or in easier terms, what order they're in. So we're going to create a variable called lock combination. And this is going to be an array of integers, more specifically 4 integers. So make it integer, and then up here, change this to an array. And we want to add 4 elements, so 1, 2, 3, 4. So this will be our code. We can make it something by default. Let's just say like 9, 5, 1, 6, or something like that. And let's make this integer instance editable so we can make multiple locks and multiple codes. So if we click on it now and we go down here, this lock combination is now available and we can change it to whatever we want. So we can make a second lock and make this one 0, 0, 0, 1, or whatever we want our lock to be. All right, back into BP lock. So let's create a function, and this will be called check code, and this will just check to see if our code is correct. And we'll do this with a for each loop with break. Now this for each loop will only break if it finds an incorrect number, which it'll do every time unless we have the correct code. So the array is this dials array. And in the array element, we can get the number variable. So these dials, remember, is an array of BP lock dial, and we're grabbing our number variable from BP lock dial in each array element. So we just want to make sure this number is equal to the correct number in our lock combination. So we have our lock combination, but this has 4 different numbers in it, and we want to make sure the number is equal to the correct one. And we do that with our index. So if we get a get a copy, and this is the index of our array. So we have 4 array elements, so there's index 0, 1, 2, and 3. And we can get the index by plugging this into the array index. So now, if we ask if these two are equal, it's asking if the first dial is equal to the first number, second dial is equal to the second number, third dial to the third, etc. So let's create a branch right here. And if this is true, we need to set a local variable for local success. This will be a Boolean and not an array. If the number is correct, we want to set local success to true, which doesn't mean this function is over, because it can easily be reset back to false if one of them is wrong. which we can just add now. So let's set local success to false. And if it's false, we want to break the loop. Because, here, one sec, let me create this reroute node first. Because it's false, and then we continue and say the next one's right, and it would set local success to true, and then it would end, and it would think the entire code is right, because we have our entire code collected in this Boolean here. So we need to break it to stop checking, because it's already wrong. So once this is completed, we just need a return node with an output called success with a question mark. And our local success will just be plugged into there. So let's create a quick way to just change each dial for debugging purposes. And we can just use some number keys. So in the event graph, and we can just create input, let's just use H, J, K, and L. So H and key. Sometimes that narrows it down. Input J, input K, key. Sometimes you have to find it, sometimes you don't. Input L, key. Okay. And we'll just use these to turn each dial to debug. So we can just get the dials, and we'll need to get them at their specific indexes. So we get a copy, and let's just copy that 4 times, plug it into all of these, and we can just choose what index we want to reference. So 0, 1, 2, and 3. And when we press each specific number, we can just call rotate dial, which is our event from that specific dial. After we rotate the dial, we want to check the code. So let's just type in check code. And actually, before we check the code, we need to call a retriggerable delay of 1 second. Oops. Or I believe it is half a second, because we don't want to check the code until the dial completes rotating, because it's when it completes rotating is when the number is set. So we don't want to check the code before it sets its number. So we will have a retriggerable delay of half a second, and then we will check our code. And to be safe, we could even make it something like 0.6 seconds. But none of these inputs will work unless we enable input. So before we do any of this, we can just enable input from our player character. So we can cast to HG player controller. I'm sorry, controller, not character. Convert to pure. The object is get player controller. And we're actually going to need this as a variable later. So we can just create it as a variable now. So promote to variable, player controller. And after we do that, but before the for loop, we can just enable input. I'm going to pull it kind of like up here so we remember to remove it later on. The player controller is not the target, but it is the player controller, and the target is self. So we want this actor to be able to take input. So now pressing these buttons will actually register. And very lastly, let's print a string to see if it was successful. So this should only print true if we get our code correct. It'll print false every other time we turn a dial. So let's test it out. So let's click on this, and just to check our lock combination, it's 9516. So let's hit play. And let's go check this one out right here. Actually, real quick, I'm going to delete this because we have print strings in the upper left and I don't want them all duplicated. So check this out. So 9516, I believe. So I'll press H. I'm going to keep pressing it. If I spam it, you'll see it won't let me continue to rotate it until it's finished rotating the last one. So pressing it as fast as I can, it still goes at the same rate. We're at 9, Let's get to 5, 1, and 6. Okay, I'm at 5 right now. You see it had been saying false in the upper left the whole time. And when I press it once more, it should say true. 6, true. So now our lock is unlocked because we've given it the correct code. I know this episode's been going on fairly long, but a fun little thing we can add before we wrap up this episode is just plugging in that animation at the end to let us know that we have unlocked our lock. We can now get our hands on the good old goodies on the other side of the door, or inside the chest, or whatever you want to put your lock on. So back in BP lock, if we go into our check code, I'm sorry, not our check code, our event graph, after we check the code, instead of printing a string, if it was, oh, sorry about that, if it was successful, we can just play animation for our lock, so for our skeleton mesh right here. And the animation to play is our lock open. Compile and save. And let's test this out now. So hitting play, 9516 is the code, or is it 9156? Let me double check that. 9516. Okay, I was right the first time. All right, so I'm hitting HJ, K, and L to change them. 9, 5, 1, and 6, and then once I reach 6, after I hit it again, it should play the unlock animation. There we go. We have now unlocked our lock. Alright, I know it was a bit of a long episode and there was a lot of programming put into it, but I did my best to explain each and everything that we were going through, and I hope you managed to stay with me the whole time, and I also hope this inspires you for new puzzle ideas and different ways you could make just this lock in general, since there's a lot of different ways to do locks. We're not quite done with it yet. The next episode we're going to be creating a more intuitive way to actually change the lock numbers, because you don't want just players hitting 4 random keys on your keyboard that you can also do at any length. I can still change them from here if I want, so we don't want that. But since this episode is getting long, we are saving that for the next one. So I'll see you there.